Hello everybody. What if three complicated ratios are actually hiding one simple truth? Today, we will crack a powerful ratio and proportion problem using smart substitution and symmetry tricks. We are given this problem statement wherein these three ratios are given, and then we are asked to prove that each of this ratio is equal to these two expressions. So what is the intuitive idea behind to solve such problems? So when multiple ratios are given, we can assume a common ratio, let's say k, and then using the theorem on equal ratios, we can combine the numerators and denominators. Then, through algebraic manipulation and symmetry, we transform the expression into the required forms. So now, let's deep dive into the solution. So we are given these three ratios in the problem and let this be equal to k. Then by applying the theorem on equal ratios, we can add these three ratios and this is what we get. And upon simplifying both the numerator and denominator, because you see there are terms in common. So by simplifying this, we arrive at this expression. And thus, since this is equal to k and also these three equations given in the problem, even these are equal to k. So ultimately we can define that all these ratios are equal. Now let's move to the second step of this problem. And in the second step, we are asked to prove that all those ratios are equal to this expression. So here intuitively, we can say that we need squared term in the denominator. Thus, multiplying throughout the one equation by p on both the sides, this is what we get. And then using the theorem on equal ratios, but this time remember that we are talking about subtraction. So this is what we get, and we arrive at equation number 2, and this is what we are getting. Now similarly, using the second ratio and multiplying throughout by k, this is what we arrive at, and we can name this as equation 3. Likewise, multiplying throughout by r, considering the third ratio, this is what we get, and we mark this as equation 4. Now, if you compare all 2, 3, and 4, so we see that there is some analogy, and we can apply the theorem on equal ratios, and this time we can add because in numerator we need this particular term. And by adding 2, 3, and 4, we observed that there are some terms in common. So we can cancel it out. And this is where we arrive at. And this equation is also equal to k. And we can name this as equation 5. Now from equations 1 and 5, we can conclude since both of them are equal to k, so these two ratios are equal. And finally, we prove that all the given ratios are equal.